Hello everyone and welcome back to While True Learn. Okay, before we get started, when I was checking out the video of this or editing the video of this, I realized that I could make this cheaper, which is very important. And I realized the benefit of the servers, which is that it is so quick. But I don't think that at this point we need that speed. So I'm just going to use a decision tree color again and just go with any and any. Pop that there, link that there, link that there, and link that there. Yeah, let's try that. So I'm just using these ones just as those servers. I wish I could reorganize these while it was running. This one actually does, oh wait. The other thing I could do is we do have the custom nodes which splits it red, green, and blue. So we could use that instead of having these. Now these take 0.6 seconds. I think that takes 1 second in total. So this one does 80 users per day. Or it does more. Yeah, it does more. Oh no, it only does 80. Where is our bottleneck? This is not getting filled up. The sifters are not getting filled up. Oh. Okay, so that's why we can't use that there. We need to use the servers because the other ones are just not fast enough. It doesn't pick up enough. Now, without increasing the cost of this, we could actually improve, I think. Let me just check one thing here. Red, green, blue. We have a red, green, blue here. Only RR. Red, green, blue sort. What? Okay, so it can input 0.05 seconds, but output. So wait, does that cost us? No, it doesn't cost us more money. So that's 0.3 seconds. So that's red, green, blue. So let me just get rid of these and see what happens when I do this. So that's red, that's green, and that's blue. Is that better or worse? In any case, that doesn't cost us anything, so I'll use another one of those. Where is our red, green, blues? There we go. So I can just sort it like that. Red, green, blue. Test run. Okay, let's see how that does. So what this does is it just splits that input into two sifters. The output is not getting backed up. So this one is fine. It is just the sifters. Wait a minute. Okay, so this one goes there, comes into these two sifters. Okay, let's see how high this goes up. I mean, I'm expecting it to go up to at least the 118, 119 we saw before. Yeah, that's about it. because these sifters are blocking it. I can make this more efficient by the trash can over here. Move this down because that's red up in the top and green down here. I'll move these way down here, and okay, decision tree, another decision tree, and we're just going to use any from there to there, and another decision tree, any to any, pop that there. Now we're going to need 4 sifters. This one can go there, this one can go there, 1, 2, 3, 4. The circle goes there, and that goes to trash. And we'll do the same thing here. 1, 2, and we need 2 more of these. So this is any, all of them need to be any. So this goes there, that goes there, that goes there. I'll move this down a bit. That goes there, move this up a wee bit, and 2 more sifters. Okay, there we go, there we go. Circles are correct, and everything else gets trashed. Okay, that's a complicated system, but it is mostly duplicated. Now average destination time is a while. Oh no, it should be, oh yeah, it takes a little bit longer. It takes 0.3 seconds longer because we have another decision tree stuck in there. Let's see if that improves the users per day. It seems to be going up. It feels like that is going quicker, but that's just my instinct, my kind of gauge. I think it got up to 108 very quickly. Yep, it's definitely going up. That's definitely better. And only $4 per second. Yep, they'll take that. Release. Accept. Okay, that's a lot of users in Gamazon, and I want to patch that as well because I realized that I don't need to do that because I can use our RGB node again, RGB sort, which is very quick. And I also want to use a server because we will almost certainly need it. And we need another RGB sort. Oh wait, RGB sort and RGB quick sort. What are these? Oh, that requires 2 servers. Yep, no thank you. Wait, if I put that there, is that going to, oh yeah, increases my cost. I don't want that. RGB sort, 1 there, 1 there. And what we're going to do is red goes there, green goes there, and blue goes there. Test run. Okay, those are getting a bit overloaded. We are getting a large number of users in here actually. Can't go back. 100, that's not going to be enough. 150, 160, it's still pretty decent. I wonder if I should make the effort of sending some this way. That seems more complicated than it's worth. Or I wonder if it's worth it. Okay, 300. Release. Just wanting to check. 600, I need twice as fast, twice as much. So let me put this over here. What we need are 4 RGB sorts, not 2. So let's, because that's the one that was getting backed up. RGB sort. And one more. And what we will do is we will use the decision tree. Just move these this way so we have a bit more space. Okay, decision tree. We'll use any and any, 1, 2. Another decision tree, any, and there. I'll just move this down here so it's a bit tidier. So red, red, green, green, and blue. All right, test run. Okay, so right, it won't matter because these ones are just not quick enough anyway, because these were taking 0.3 seconds as well. So if I wanted to do more than 300, the only way is to add servers there. Yep. Okay, so I'm not sure. I mean, I'll keep so that's $8. Okay, that doesn't help. So I need one more at least. And let's see how that does. Because it says 600 and odd users. Would the other one have given us more output? Oh, the sifters are what's slow now. Oh, we're not getting 600 out of that. So that's not the answer. Let me just check this again. What's going on? Okay, that one definitely gets stuck, and so do the sifters. That's why. Okay, so I was misdiagnosing our problem, which is what it was. So we don't need that. We don't need that. What we do need... Oh, crud. Actually, that's not so bad. Okay, I'm just going to move this down here just so we can see them a bit clearer. We need to split our inputs across multiple sifters. So I'll put another sifter there and decision tree there. I will do any and any. Move that red to there. Move that red to there. Sifter to there. Sifter to there. And we are sending the triangle there. And we are sending the circle there. Wait, is that right? Red triangle, okay. And we'll do something similar here. decision tree, any. So this is green, right? Yep, green. So green and green. Nice. And we will have two sifters here. Triangle, oh wait, I need to change this to triangle. And that also needs to be triangle. And this goes there. Does it? That doesn't. Oh wait, this goes there. And that goes there. Okay, let's see. Okay. The sifters are still getting a little overfull there. Yeah. Oh wait, sorry. I've missed out. This one. Okay, that needs to go there. That needs to go there. My bad. Let's see now. Yeah, 100%. Yep, they're full again. I wonder if I will need to split this apart more. Yeah, I mean the RGB sorts seem to be doing fine. Oh no, their outputs aren't getting saturated, their inputs are, but then their outputs are getting saturated. And these are not pushing them out quickly enough. I mean, we're at 400. Wonder how far that'll get. 480. Yeah, that's good. I think we need like 630. We're almost there. And for $4 per second, that's not bad. Yeah, I think we'll get there. Almost there. Ah, you know what? I think that's close enough. Release. Oh, 654. That's 568. What? Can't remember how well we got in with the self-driving car. Okay, let's check here. It's Moneybag Bank. We wanted to create a system for sorting candidates for receiving credits in order to reduce the number of errors. We would be happy if you'd complete the task before the holidays. Okay, let's accept. What? That's all? I am tempted. Okay, what is RG divide? RGB sort, there we go. Easy peasy. Red. Oh wait. I don't have... Oh wait, maybe the blue can just get stuck there. Green. Test run. Oh. So what am I supposed to do? Since I don't have a trash can. The node compares sockets colors with elements color and chooses the socket with minimum amount of errors. What if I use these as a storage place for the blues? Yeah. Wait. We ran out of time. Oh wait. What the hell? Red, green. Blues are going there. So what is it waiting for? 3 out of 40. It's missing one. So that's 3 out of 3. Good. But it's missing one there. It's missing one single green. But that doesn't seem right. There's 40 there. There's only 40 there. And it's wanting 41. Why? And how exactly would that work? I can't convert it. 3, 3, 40, 41. That doesn't sound right. What does that do? Okay. Wonder if it will create a new one. Oh, wait. It only needs 75% accuracy. So 75% accuracy means, okay, so maybe I can, okay, I get it. So I can just send that there, and I can send that there. There we go. That's just cheating. But that's fine. Next project. Before I check, I want to see how this is doing here. Holy crap. Okay, self-driving car is under massive overload. Let's have another look at that. How can we speed this up without spending more money on it? How do I convert some of, okay, let's check the custom nodes. R else divide without blue. That's 1 second, that doesn't matter. Only red fast, only triangle, whole, 2 parallel, 4 parallel, only block, no text, only red parallel, WB, WG divide, RGB sort, quick sort, RG divide 50%, red green. Wait a minute. Well, that's 50% accuracy. I mean, the only thing I can really think of is to split this out even more. Let's see. Okay, they're just going out through there. And the sift is once again what's starting to get clogged up. Can I? So that's looking for circle, right? So let me go back here and look at emails. So let's check each of these. School problems. Okay, I don't care about that. Nope. I need something with a sift. Decision. So can I just change these completely now? Okay, sift. So this gives you the triangles. Okay, that's not what I... Okay, I don't have access to the perceptron there. Decision tree color. This is not what I need, not what I need. No, no, decision tree color. Okay. RGB sort, RGB sort. What's this? So this must be the current one. Okay. A more complex structure than a decision tree, but it can recognize more classes. I don't see how that would help. Would it help? Hardware. Increases work speed 5%. That won't help. That won't help. Sockets processing queue. I don't see how that would help. Let's have a look. Okay, so that's RGB sort. That takes 1.4 seconds to determine 3 classes. So we've got 1, 2, 3, 4, 5, 6, 7, 8 of these going, and that's still not enough. Okay, fine. Then let's have more of them. Sift. Just going to stack them up like that. Decision tree color, decision tree color. Expert system. No, that takes 1 second. Just checking, is there anything else? R else divide without blue, only red fast, only triangle. That's 1.2 fast, so that doesn't help us. All, what's G? Oh, green. Red, else divide. Okay, if it's not red, split into 2. Okay, oh, I see. Will that help us? No. Okay, so we just need to use base nodes. Decision tree, any, and we're going to use okay, I need to spread these out a wee bit so I can reattach these. That goes there, that goes there, that goes there. Decision tree, any, that goes there, that goes there, that goes there. Okay, so I'll pop these up along like that. And 2 more decision trees. 1, 2, any. I'll just do that. And then we need 4 more sifters. Okay, sift 1. Maybe I'll set them up and move them out the way. So circle there, everything else trashed. Circle there, everything else gets trashed. Oops, wrong one. 3. Circle there, everything else gets trashed. Sift. Circle there. Everything else gets trashed. Alright, let's test run that. Because I guess the most important one is that they catch the reds. I wish I could move this around when it was processing it. Wow, it's really getting slow now. Because we've added another 0.3 seconds into that frame. Will that work? I wonder, $4 per second, so that must be for every second of processing time. That may not be great because we are adding another second in here. Well, we're adding a third of a second. I guess that's why the servers are cost efficient, because that's 0.05, but it costs you $2. Huh. That's definitely going up. Okay, I'm going to do the same thing here quickly. So 1, 2, and then we're going to have 1, 2, 3, 4. So set all of these to any. Don't like this very incredibly messy setup, but I can't think of an alternative. So this goes there, that goes there, that goes there, goes there. Pop this up. Okay. Another sift. Circle goes there. Everything else goes there. Another sift. Wait a minute. Any. Circle goes there. Everything else goes there. Circle goes there. Everything else goes there. And finally, circle goes there. Everything else goes there. Let's just do a test run. As incredibly slow as this is going to be, now I guess the argument really here is how long does it take to process for each user and how much does each user pay? I don't know the answer to that latter question. I know how much it costs because the average time is what, 35 seconds? And that's a good chunk of change. 35 times 4 is like $140. That's going up. 40 times 4 is 80. 40 times 4, $160. If it's 50 seconds, it's going to be $200. So it's a big question as to, well, these sifters are not getting overloaded now. That is interesting. So we've reached the capacity of these sifters. And we can work around that easily enough. When we've got these two RGB sorters, and I don't think adding another decision tree in front of that is not necessarily going to make that any faster, or will it? Huh. Okay, I'm just going to deploy this and see what happens. 720 users. There's no way. There must be something I'm missing. 1.4 seconds. Reinfo, that's coming soon. Coming soon. Stochastic gradient descent. Okay, the only thing I can really think of is it's not like I'm buying anything else. I mean, 5% is not much. Let's try patching that. Test run. What's happening here now? Talking about a 5% speed increase, that's not a lot. Yeah, both of these are clogged up. The only easy way around that is to put another couple of servers. I would need 2 more servers and 2 more of these, and then I would reconnect them back in. Which I don't want to do because that would take our cost up a fair bit. And there is the RGB quick sort. Okay, I'm gonna let that be as it is. We will do one more and we will call it border crossing control system. Good afternoon. We are offering a contract on improving the security system of our borders. Our cameras detect a lot of violators. You must write a system that will determine the type of vehicle that criminals use and pass the violation protocol to the optimal checkpoint in order to arrest them. The most popular types of crossing the borders are on foot, by car, with the help of a giant slingshot. Okay. So we just look 50% accuracy there, 100% there, 100%, 90 there. Wait, so why? Okay, so triangle goes there. Okay, everything else can go there. And then we have server, because we are basically just needing to duplicate it from what I can see. Oh no, it's not. I'll put a sifter there, send that in. So triangle goes there, and everything else goes there. I wonder if this is going to take too long. That's $1,500. Yep, that's pretty long. You ran out of time. Okay, fine. So we're going to need 2 more of these. Don't think we need a trash can though. Plonk that there. Oops. pop that there. Add a couple more sifters. And we'll sift something else this time. So triangles are being sent there. Oh, that's really all I can do again, because triangles can't go there. So I have to filter them out. Yep, same here. Wait a minute. That should be the other way around. Triangles should go there. Everything else should go there. Triangles should go there. Look at them. It's like a... Okay, that's moving along much quicker. Okay, I think part of the issue here is going to be that they're expecting a certain number of those items. This one's expecting 40. It should be fine. It should be, if there are enough triangles, they should all go there. Or maybe not. You ran out of time. 46 out of 30. Yep, 30 out of 40. That's our failing one. So we need to... Yep, that's the one where we need to send more triangles to. That's fine. I just do that. Let's try that. Alright, regardless of whether this succeeds, I will have to call this episode, because we are way over time, and we'll sort this out the next time around. Oh, we might not make the 20 there now. Wait a minute. Yeah, that's only 10 there. So, oh, actually, I should have checked that, because so I know which one we got too much of. So this one, I could probably plonk there. Okay. Because that only needs 50% accuracy as well. Let's see. Will that work? Pretty close. There we go. Perfect. Good thing. Wonder how much money we will actually make from this, because we've got 3 servers there burning a lot of cash. I like how that, there's the number up there showing us how little money we're going to have made by the end of it. Man, these sifters. Oh, okay, so well, it's not like we have those color nodes to split them up, so it would have made sense for us to split some of those things up so that it takes up less time. Next project. $911, that's not bad. Okay, accept. Oh. That's minus 412, 3,695. Okay, accept. That's a lot of money. Accept. Perfect. So on that very good note, we will call this episode. I don't know how to fix that overload. I will need to have a think. But that's fine. Thanks very much for watching, folks, and I'll see you next time.